Hello friends, welcome back to another video. So in this chapter we'll build a local RAG assistant. This is one of the most important, I feel this is one of the most important chapters in this whole journey of learning the basics of Python, which is like good enough to start your way around AI and other tooling around that. So it's where everything comes together, like Streamlit and your RAG and chunking and memory. So here we'll take a RAG pipeline from the previous chapter and add a simple user interface using Streamlit. The user will upload or basically provide a document. The app will process it and split the document into chunks, create embeddings for those chunks, and then let the user ask a question. This app will retrieve basically a relevant chunk. Based on that, build a prompt, and then the local LLM will generate an answer that's shown on the browser. So that's not communicating to the LLM, local LLM via terminal, which is nice. And this is a real, basically a local AI application pattern, which isn't production ready, but it demonstrates basically the main architectures of many document assistant systems that you will build in future. So we'll show how a retrieve chunk, or at least talk about why showing sources matters, because if you have noticed or used any of the popular AI models online, like Perplexity or ChatGPT, you might see there are some references to some web pages or news articles or official documentation. So in real RAG applications, user need trust, and if the model gives an answer, the user should know where the answer came from, and that's where citations or source snippets, document names, and even confidence indicators matter. So let's be honest about these limitations, because every solution has a limitation. This app, which we are going to demo now, is running locally, and the index may be stored in memory, and the embeddings may need to be recreated when the app restarts. So of course there is no authentication. It's not at all a professional looking app. There's no RBAC or permission model, and of course as it is local, there's no production level monitoring. So it's okay, because we're gonna experiment, and it'll basically solidify our all the learnings from previous chapters. So yeah, let's go and move to our demo session, demo part. So yeah, readmes, we need a bunch of files, I mean libraries. We have installed all of them previously, so we don't need to do that again. Let's see what's our code. So we're importing some framework, NumPy, request, Streamlit, and then we have a bunch of functions. So this one is used for chunking, and then we have the main function. So let's go ahead and run it in our terminal. Yeah, so before we go ahead and run this thing, we should also look at the platform notes. So for example, a team will, if they build on run this similar solution, then they would obviously have access to all the learnings from couple of last all the years, and with all the engineers who would have probably contributed in their documentation system, like Confluence or something similar to that, the wiki. But here we just have a one-liner document, and now to trigger this app, we will have our Streamlit command, which is like so, and this will take us to a browser. So I'm gonna upload this one, and yeah, the question is already there. So let's run RAG, our trigger to RAG, and this will you also notice the response time is quite fast, because we are really uh, calling the exact chunk. Now let's change a question which is not at all related to uh, our context, our document. So let's see, why do we need AWS S3, which is totally not related, and let's see what's the response. Yeah, you see, in the context of this, so it is taking a bit of extra time because it has to look through all the information related to S3, and then it also needs to answer in a way like as to why do we need it, and then prepare the response. So there's no chunks or to compare from the query. So yeah, that's how it is different, and it takes a bit of a longer time, so the latency is also higher. So now that you have seen that we have built a local RAG assistant with Python, Ollama is the local LLM that we have used, and we did the embeddings, we did the retrieval, and then we displayed everything. We created an interface for user to interact with the model using Streamlit. So that's how I would say that's as simple as it gets. So in the next chapter, we'll start turning the AI logic into an API, so that we have like a layer of abstraction. So I will see you in the next video. Until then, have a nice day.